All right, fundamental theorem of algebra means that whatever the highest degree is, in this case 5, right? 5, 4, 3, 2, 1, nothing. That means that is the number of solutions I need to find. Taking a look at the graph, the solutions, remember, are x-intercepts. So I can see 3 of the 5 right now. That will get me from a quintic, right, 5, down to a quadratic where I only have x to the second power. So we need to use either long or synthetic division. The order doesn't matter. So if I just want to create some order, I'm going to start with 2. Coefficients 1, negative 3, 3, negative 4, 4. Bring down the first one, we get 2, we get 1, we get 2, we get negative 1, we get negative 2, we get 1, 2, we get negative 2, 2, we get negative 4, 0. That is good because I cannot have a remainder, otherwise I did something wrong. So I took care of that. If I'm going to go in order, next thing is 1. Let me move that up just a little bit more. So that gets me down to, this would have been x to the 4th power. So I'll bring that down as 1. 1 times 1 is 1. 2, 2, 1, 1, 2, 2, 0. That's what we wanted. This would be x to the 3rd power. Can't deal with that just yet. So I'm going to take my last one, negative 2. Bringing down the first one, and we get negative 2, 0, 0, 1, negative 2, 0. So this is now x squared plus 0x plus 1. So that means x squared plus 1 equals 0. Subtracting the 1, x squared equals negative 1, and if we take the square root, we get x equals plus or minus I. So solutions are 2, 1, negative 2. Those are all from the graph, and also positive I and negative I. That gives us all 5 solutions. That's what we wanted. So even if you take a look at the graph, if all 4, in this case, solutions are present, we want to make sure you can actually show the work to get the answers as well. So that means I want to take and put everything on one side. So notice we now have negative 13x squared and plus 10x. Everything is in order from 4, 3, 2, 1 for the coefficients. Notice we do have an x on everything. So the first thing we do is a GCF. That gives us x equals 0. So that takes care of one of our solutions right away. After that, we can divide by, it looks like 1. Okay, if I divide by 1, we can get ourselves down to this quadratic. My options after that are to go ahead and continue synthetic division, or this one happens to be factorable. We know that because the 2 solutions left on the graph are nice integer numbers. So if I take x plus 5 and x minus 2, that'll give me 3x in the middle, leaving me solutions of negative 5 and positive 2. So all 4 graphs we're supposed to get are present. So find all the zeros. Here this time we only gave you 2 of them are shown on the graph. It means the other 2 are imaginary. They don't actually show up on the graph. So if I divide by 3, again taking coefficients from the original 1, 1, negative 7, negative 9, and 18, straight from the original polynomial, and divide it out. This would get me to x to the 3rd power. Divide one more time gets me to x squared. There are no factors of 2 that add up to 1. So the quadratic formula, nice little review. This section is going to review almost all of the last chapter. So we end up with solutions of 3 and negative 3, along with negative 1 plus or minus I root 7 over 2. So that gives me all 4 answers, which was our fundamental theorem of algebra. All right, hope that helps. If it just says find the number of roots, we're just looking for the highest degree. There are 4 roots here, 4 solutions. Here there are going to be 14.